Hi guys, my name is Frances Richardson, and today I'm just going to go over a quick review of electron configuration for your Chem 2 class. So I have this handy dandy periodic table brought up here that actually has a lot of the orbitals written out for you, so it makes the configuration a lot easier. So we're going to start off with an easy example. We'll just use oxygen. So basically what you want to do is you just want to go through every row of the periodic table, filling in the different orbitals until you get to the atom that you actually want. And so to start, the first thing that you want to do is identify how many electrons you actually have in the atom that you're looking at. So oxygen in this case has 8 electrons. So we want to figure out, we want to keep filling orbitals until we get to those 8 electrons. So the first thing we're going to do is 1s2. So this accounts for the hydrogen and the helium. And then we move down the periodic table and we do 2s2, which accounts for lithium and beryllium. And then we move over to the p block and we do 2p4. So 1, 2, 3, 4 to get to oxygen. And then as a quick check, we just tally the total number that you get from all of your superscripts. So we should get 2 plus 2 plus 4 equals 8, which goes back to the number of electrons that we originally identified. So that's a quick check to just make sure that you've done your configuration properly. So that's basically just how you go through and do it. But real quick, we're also going to look at kind of one of those exceptions to the rules, or one of the little tricks that you might want to remember, or it's an odd case. So if you look down here in the D block, this tan section of the periodic table, there's something that happens whenever you're in the 4th or the 9th spot, and that just has to do with the stability of the orbital. So basically, the D block prefers to be either half filled or whole filled. So either the 5 electron spot or the 10 electron spot, and if not, it just finds itself in a very unstable position. So if we take a quick look at copper, and we did the electron configuration for that, we'd end up doing 1s2, 2s2, 2p6, that's 4, 6, 3p2, 3p6, 4s2, and then 3d9. So anytime you see a 9 or a 4 as a subscript on your D, you're going to immediately think, oh, that's not very good, I want to change that. So what actually ends up happening is we end up donating an electron from the S shell and taking it to the D shell. So if you do the shorthand version of this, you end up getting argon to account for that, and then you'll get 4s1 3d10. So this guy is a lot happier, and since the s orbital still is half filled, it's still relatively stable compared to what would have been if this was almost filled. So that's a much more stable configuration. So the same thing happens if you consider something that's in the 4th spot of the D block. So in this case, your electron configuration would be argon, this is just the short form again, and then 4s1 3d5. So that's basically it for electron configuration. Hopefully this makes sense. Again, if you need more help, I always have office hours. Monday, Wednesday, Friday, 9 to 10, and Monday from 3 to 4. And I also hold a workshop from 6 to 7 on Wednesday evenings. All right, thanks.